5 times 5 is?
25.
Yeah.
Hey folks, welcome out there. It's Mathline time and you have found me. I'm Ernie Roberts. I am your host for this afternoon session. Folks, this is our last call-in session for this round, for this season. We'll be back in August, so don't worry. But we want to make it a good one today, all right? So number 844-686-2378 is your chance to call in. We'll get some problems worked together live on the air. Now, that doesn't mean you can't send me problems and I can send you back answers or solutions and stuff throughout the summer, but it does mean today is kind of strike while the iron is still hot. We've got about, 25 more minutes here, and you're going to be able to connect with me, all right? So we want you to do that. That number again, 844-686-2378. We got Cooper out there working the phone today and want him to have a good time while he's waiting for you, all right? So give him a call, 844-686-2378. We'll talk to me live, and in the meantime, let's go ahead and check out today's problem of the day. Jadyn has used up 1/3 and 5/12 of his travel budget on food and lodging. What fractional part is left? Now, we have a situation there. Some of you are going like, well, Ernie, don't we need to know how much money he had or how much money's allotted? No, this is just asking about fractional parts that are left, all right? So let's take a look at this thing. It's not a very difficult one, but you know what? Because some of you like to have money, I'll take this one step further probably and add some money into it. How's that? Everybody like that? Good. All right. Let's see where we're going to go with this. First of all, he has used up 1/3 and 5/12 of his travel budget on food and on lodging. I'm assuming it sounds like it would be pretty much a respective situation. In other words, 1/3 of it was going for food, 5/12 was going for lodging. So he's got a little bit left over because I know those don't quite make one, okay? It doesn't make up the whole budget, or unfortunately could go over, but it didn't go over either. So let's check and see what we have left over. First of all, we're going to add them together because those are basically their expenses. So we're going to take 1/3 plus 5/12, and we're going to go for a common denominator, all right? Because it's fractions. Oh, whatever you do out there, do not tell me that's 6/15. That doesn't fly. Everybody knows that. Nod your head. Hopefully you do. Now, what we are going to do, though, is figure out some way that we can get the same number in that denominator. Now, I look at 3 and 12, and some of you say, oh, we'll multiply, we'll get 36. Well, 36 is a common denominator, but it's not the LCD. It's not the least common. Let's go for smaller numbers just because they make things a lot easier to work with, and you don't have to do a simplifying on down the road, which you might have to do if you don't get the LCD going here. So let's go for the LCD. What is it going to be? It's going to be 12 because 3 divides into 12 evenly. And what number is going to make that work? A 4 right there. So I'm going to put a 4 in the denominator. Now the rule, yes, if we're going to change that denominator, we've got to change that numerator also. And we're going to multiply that top by 4 also. And now I'm seeing something. I'm seeing 4 over 12. Hope you guys are too. 5 over 12. And now I have 9 over 12. Now, I mentioned something about possibly reducing down. Boy, if we had 36, we'd have a lot of reducing to do. But as it is right now, we've even got some reducing that'll go on here. Notice what's happening here. I've got 9 over 12, which will be nice. It'll be nice. It reduces down to, you got it? What are we going to do? Let's divide by 3, both places, all right? And that's going to bring us down to 3/4. Well, that's pretty nice. That was what 9/12 gets us. So, are we done? Is that the answer? No, we are not there yet. What do we got to do to get the answer? We want to know what is left over. So you know what? If you had that as a good old test question on a TCAP or a whatever they do in Kentucky, an ACT, SAT, we also still get problems like this on those too. Yeah, they would use that as probably one of the answers to say, oh, did you finish reading your problem? Got to go to the end here, all right? So how do we get the fractional part? Well, we've used up 3/4. That hopefully tells you we have 1/4 left. Now, what if you left it at 9/12 and said, well, I think I was going to use it from there. Either way, we're going to subtract from 1, all right? And I'm going to do it both ways. We're going to use 1 minus 3/4, but over here, I'm also going to get 1 minus, we had what, 9/12. So let's say you didn't reduce it, all right? You forgot to reduce it down. So again, what's happening here, we're going to break this 1 into 4 pieces. And a full unit, if we break it into 4 pieces, we got 4 out of 4 pieces there, all right? So we've got 4 over 4, that's how we're going to work it, minus, you got it, 3/4. Well, that one's pretty easy, and it gives us 1/4. There you go. That's the fractional part that's left. Now, I dug this little one over here and said, well, what happened if you might have chosen 9/12? Because I know a lot of you try these problems along the way, and you think about them. That's fine, because now we're going to break this one piece, this whole budget, if you will, into 12 pieces. And we're going to go 12 out of 12 because that's how many parts he's got if he's still got a full budget going here. He's used up 9 of those, which is going to give you 3/12. And you know what 3/12 does? My goodness, it reduces, doesn't it? It gives you also 1/4. So just be sure to take it all the way down to the end. A couple of ways we can work through it. Like I said, sometimes you reduce sooner, sometimes you wait till later to reduce. That's your call. But as long as you get to 1/4, you did well today, all right? Now, what if I give you $1,200 to spend here? Just a quick thought here. Well, you could figure out what's 1/3 of 1,200. You could take 5/12 of, what would it be? 1,200. Add those results together, or you just played it right here and said, what have we got? And then got your 3/4, and of course, then subtract what you have left over in terms of the money. What part of the money is left over in this case? If you had $1,200, I believe it sounds like you would have $300 left to spend on your own. You would have 1/4 of that amount, and that's $300. So different ways to look at it here, but that's your problem of the day, all right? Just a little bit of good old fraction action, and then I can stretch it a little bit. We can start putting some more numbers in there and letting you play with them. But for today, we're good, all right? Now, speaking of being good, let's hear from you, all right, folks? On those phones, we want to hear from you. 844-686-2378. Students, adults, young people, our children, everybody, just give us a call, all right? 844-686-2378. We'd love to hear from you on our last live day here before we head off for summer vacation. Before you all heading off for summer vacation, we will still have some new math lines. Yes, summer school will come along come June. Also, we're going to have some test prep days mixed in there with it. And again, sometimes if you send us some questions you might have that come over this summer, especially you adults, or some of you are doing summer school work, or you're doing those summer packets. Yeah, all those teachers and students, you know, that are getting summer packets to work with. Hey, all of those things, we're available. Give us a call, all right? Or even better, send us an email. I think that keeps rolling through there. Or you can check us out and ask us some questions on Facebook. We will answer to you the best we can, all right? But we're still here for you, all right? We're here as your support. You take advantage of us, okay? We hope that you will do so. Now, let's talk a little bit here about just a little bit of geometry going back here. We've got the 2 concepts that we've had in our specialized segments the last week or so, and it's on arc length and how to find area of a sector, all right? And basically, when we're talking about arc length and area of a sector, we're in a circle, and we are basing this on a central angle. You said, what's the central angle about? Well, that's the central angle right here, because it has, guess what? The center of the circle is its vertex. That's where it happens. And the idea is, if you know that the arc length is 60 degrees here, out here, if that measurement, not the arc length, but the arc's measure is 60 degrees, we can find the arc length if we know the radius of this circle, because that's a very important piece, because it's all based on how far out from the center the circle is going to be. So we're going to use this radius, which we said here is 12. The other one is 12 also. It's just basically telling us that it's formed by 2 radii there. So it is a central angle. But what's important to us is what part of the circle is this little arc right through here going to be? Well, 60 out of 360. So let's go back to a couple of quick formulas. First of all, if we're going to find arc length, it's going to be the part of the circle times the circumference, or part of the circumference, we like to say, all right? And that circumference, well, let's just put it in here for just a minute. We'll put a formula there in just a second. But we're basically going to take the part, which is out of 360 degrees, times the circumference. Now, how about that area that I asked over here? The area of your sector is also going to be, it's going to be the part, but it's going to be times the area of your whole circle. all right? So those are your two pieces we're going to need to find out. We need to figure out what is circumference. We need to find out what is the area. Well, everybody remember that? Sure you do. The circumference is what? 2 pi r. 2 pi r. The part is our 60 out of 360. And, 2 pi r. Do we have an r? We do have an r, don't we, folks? Everybody nod with me? Yes, we got a 12 right there. So we'll put a 12 there, and we'll multiply that in. That's going to get it going. Some of you are saying, well, Ernie, isn't that the same thing as pi times the diameter? Circumference is also able to be written as pi times diameter. You're right. So, again, we just go ahead and talk about 2 times 12. We'll get 24 pi, and then we'll play with this, okay? Speaking of which, let's go ahead and play it out. Let's lose those zeros. Divide both by 10. That's how come we can do that, all right? So we get 6 over 36. Fraction time. Boy, we've been talking about reducing a lot of fractions today, haven't we? So let's reduce that thing down. 6 will divide both of those, but don't just leave a 6. Got to make sure we have 1 6. There you go, all right? You got it? Everybody good? Nod. Raise your hand. I can see you. Yeah, good job. And what we got? 24 pi. I already mentioned that. Now keep in mind, these are meters. This thing is in meters that we're looking at here. Over here, these are going to be talking about square meters. That's another story. We'll get to them in just a second, all right? But let's see what happens here. Can we all do this one? I think we can all do this. Let's take a 1/6 of 24 pi, and that is going to give us 4 pi, and that is in terms of meters. Now, some of you are saying, Ernie, what in the world do we do with pi? You can multiply it in if you would like to. That's going to push us up a little over 12, all right? A little over 12 meters. You believe me? Go for it. Let's see what we have there. 12 times, I'm sorry, we're not 12 times that. I was wanting to get 12 times that. Let's go 4, and let's hit pi. We'll get there. I think we're all ready for summer vacation. Let's see if we can get pi. How about it? Let's go back and reduce that. Clear. Let's just start again. 4. Hit the pi. I could claim this as a Monday, but it's a Thursday, isn't it? There we go. As I said, it's a little bit over 12, a little over 12 and a half actually there. And those are meters, because what we would do, we would stretch. We would stretch out that nice arc, stretch it out, and that would be how long it would be, all right, from the point here to the point there, all right? So just take it, stretch it out into a nice little line segment. That's what we're doing. We're talking about what's the length there, that line segment. Now, what about this space that is in beautifully shaded red there, all right? A nice pretty red on your screens over there, I'm sure. Well, let's go back to the situation. We are still talking about a 60 out of 360 situation for our part, right? Part did not change, although it looks like it did, didn't it? That's a 60, everybody. And it's pi r squared this time. Now, I got to think a little bit about this. We get a little bit carried away here, I guess. What have we got? What have we got this time? It looks like to me we're going to have a 1/6 again. That part was easy. Well, we did it once. Why not do it again? Lose the zeros. 6 over 36 gives us 1/6. But here we got to do r squared. So the 12 squared is going to give us a little bit higher. That's 12 times 12. Y'all got that off your multiplication facts? Those you've forgotten, hit the calculator. Those you do remember them, it's 144. So we got 144 pi there. And what happens from there? We take a 6 of 144. Believe we're going to get 24 pi. Some of you say, well, that sounds like what we had earlier. Well, it was before we divided by, divided by 6, isn't it? But this is your final answer. And folks, these would be square meters. So that's all the space inside the red. Now, I'm going to ask a quick thought here. All right, while we're at it, you know me, I like to just kind of occasionally jump off base a little bit here. We got these two answers right here. Could we have done the same game for this, this major arc back here? And all the space that's basically not in the red, we'll say not in the red sector? What's back here in this? I guess you could call it light green or something. There's some different color. Could we figure it out? Well, what we would do, we'd have the same circumference, have the same area, but what part is going on this time? This time we're in a major arc land, all right? How many degrees? Well, you remember there's 360 total, right? So this takes up 300. So if we want to go for this part, it looks like we're going to be looking at 5/6 of, what did we say, 24 pi? The circumference is not changing, friends. So there's one length. And then the area of the other sector is going to be also 5, 6. And we're going to do that 144, squeeze it in there, pi. All right, we'll almost squeeze it in. And down the line here, again, how about it? What are we going to have? Well, we're going to be able to divide, it looks like 6 into that. That should give us, what, 20 pi? And over here, this should give us, I hope you're already ready to jump with me there. Wow, what should it give us? How about it? You with me? Let's go with 6 going into that. That's a little bit tougher, isn't it? We're going to divide 6 into that. Goes 24, right? And 24 times 5, I'm going to go with 120 pi. And let's notice something here. This part, the 20 pi and the 4 pi here, got you what? 24 pi. Guess what? That was our circumference for both of them. Makes sense, right? Because you're either in the red part or you're back here. You don't get any gray areas, no pun intended there, all right? And the areas, how about it? 120 pi plus 24 pi gives you that 144 pi that you've got back there. So again, all sorts of sectors. We were talking about the 60-degree one, but like I said, I like to go crazy and look at the other things too. So we also talked about the 300-degree one there. Gives you a chance to figure out a lot of good things. And I hope you've been watching our circle series. Tomorrow we got one more specialized segment on circles. We're going to look at inscribed angles. Going to leave them for a little bit, but I guarantee you we'll be back again toward the end of summer and maybe even middle of summer, and certainly in the fall. We will do some more circle study for you folks who are into the geometry, and I know that's an area that many times is a rough go. So again, that's why we do these specialized segments, by the way. It's not that we have nothing better to do on a Friday or on a holiday or in the summer. We want to give you some things that help you. They're tutorial experiences and hopefully some references you can come back to and say, hey, I remember that, or I know where to find it, YouTube or Facebook, as we say, all right? So looking at that, we've been dealing with the little geometry moment there. How about it? Let's get some calls going, all right? 844-686-2378. Hopefully you've got those things in your speed dials and ready to call us, all right? Give us some calls. Simplify and write in scientific notation. Next little game plan we've got here. Let's do actually a little arithmetic, all right? Maybe we could call it algebra, pre-algebra. It's a little skill, isn't it? So the idea here is we are going to take this scientific notation piece right there, this 7 times 10 to the 4th, and we're raising it to the 3rd power. Now, I'm going to long ways it this time, because usually I just say, here's the rule, blah, 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 okay? Let's think about what this is actually telling us to do. It's actually telling us to take 7 times 10 to the 4th, and take that same parenthesis, times 10 to the 4th, and 7 times 10 to the 4th again, all right? Now, there are no pluses in here. Everybody notice that? Nod with me? Yes, no pluses, all right? You got it. Don't see any pluses. Everybody's agreement. That's what I want to make sure. Now, what we do have are 1, 2, 3 7s that are hooked in by times to a bunch of 10 to the 4th powers. So let's take care of business. A little commutative property moment. Let's shift some things out. Let's pull the 7s all together. Let's multiply them all together. And it's going to give us 7 times 7 times 7. You know what? We probably want to go to the calculator on that. So let's see what happens when we take in. Let's clear out what 4 pi was given us. We've gotten that down. Let's go 7, and we're going to, well, it's multiplied 3 times, so why not? Let's raise it to the 3rd power. Hint, hint, that's something we should have done to begin with, but we'll be all right. We got 343. So far, so good. Everybody see what we did? Now we've got to deal with these 10 to the 4th, 10 to the 4th, 10 to the 4th. Now, I don't really want to type all these zeros that 10 to the 4th, 10 to the 4th, 10 to the 4th is going to give me. So I'm going to remember, if I have the same base here, what do I do with the exponents? I add them together. It's like having a 10 to the 4th, 10 to the 4th, 10 to the 4th. You just take, oh, you've got 10 to the 12, right? All together. And that's exactly what it is. Don't want to break them all down to a bunch of 10s, do we? So we got times 10 to the 12th power. Now, where are we going to go from here? Because so are you going like, oh, goodness, that's nice. You got an exponent on the 10. That's cool. You've got 343. Not so cool if we want scientific notation. So what we got to think about here, scientific notation means the numbers look sort of like a 7. Well, we can't make 343 become a 7, but we can certainly make it a number between 1 and 10. Don't want to get to 10 because then we're out of scientific notation form again. So you're saying, Ernie, what's that going to do? Let's look at a 3 and 43/100. 3.43 as we love to call that, all right? Going to change that. Now, I'm still going to have a multiplication here, and I'm going to have a 10. But I just made this number smaller. You say, well, how much smaller did you make it? I divided by 100. I just knocked off 2 powers, literally. All right? I divided by 100, 10 to the second, which means if I knock it off here, I've got to bring it back somewhere. I've got to bring it back over here. So we're going to add those extra 2 powers, those extra 2 powers of 10, that is, and we're going to put it right up there, not 12, but 12 plus 2. All right? And what's 12 plus 2? Everybody's got that on the tip of your tongues, right? Times 10 to the 14th. And that, friends, there is your scientific notation. We had to bump up a little bit to accommodate, and the whole idea with scientific notation is, yes, we always like to have a digit between 1 and 9 here. If we see a 10 pop up, that means we need to move the decimal again. All right? So that's your story on scientific notation. Just a little quick example there. We are going to also do a few series on that with our specialized segments sometime in this year or the next, all right? So there's always more options to do specialized segments, isn't there? My, we just never seem to get enough of them. Speaking of which, can't get enough of you guys today. Let's have some phone calls, all right? 844-686-2378. Want to hear from you as we are beginning to wrap up our last show for the live part of our season. We've got plenty more fun things to go with our specialized segments in our summer school and test prep series that will be running throughout the summer. So you don't want to miss out on that. Now, a little off the wall moment here. How about it? Let's look at some interesting things here. These are what we call conditional sentences, and coding and arranging them. And it looks like there's a lot of things going on here. Let's look at what's happening here. We want to arrange them into a logical order and to arrive at a new conclusion. You're saying, oh my goodness, well, what kind of new conclusion can we have? Well, let's see maybe who starts and who finishes pretty well here. Let's take a look here. We've got Jack jumping rope, Mary making macaroons, okay? You say, what's that about? Conditional sentence, if-then form. So let's do this. Let's code them, as I say. Let's take Jack jumping rope, which is all about a bunch of JJs there. Let's do some M's here on the other side, and we got Mary making her macaroons, all right? Now, if Lisa does not leave, then Peter paints pictures. All right, well, how about that? Oh, how do we do a not leave? How about this? We'll put Lisa, but we're not saying she's not leaving, so she's not leaving. Then Peter, though, however, will do some painting. All right, that's interesting, isn't it? And if Lisa leaves, oh, Lisa's doing 2 different things here. If she should leave, then Mary won't make macaroons. So we have the not symbol and macaroons. A little geometry going here, little logic moments going. So let's see what happens. If we can drop up my lower third there, let's see if we can pull this thing together, all right? Let's see. Let's start with Jack. How about it? Let's start with Jack. And we've got, let me rewrite them here. We got Jack having Mary making macaroons. I think that sounds good for Jack. He'll be good. We also have, what did we say, this not L, that's not because I made a mistake, that's just the way it works, leading us to Peter doing his painting of pictures. And then Lisa leaving will have Mary not making those macaroons. We've written that down before. We just bring it down here where we are. What I want to do is get this thing to start. I want Jack to take Mary making macaroons, but I want Mary to be making macaroons and see what happens from there. Well, you see what's going to happen here? Are you ready? Everybody good? If we need a positive M from this one to move in. So here we go. We're going to make Mary's macaroons mean that Lisa won't leave, all right? So we're having Lisa not leaving. And how about it? Let's let Lisa not leave again. And then Peter will be painting his picture. So it looks like to me, and some of you hopefully figured it out, it's a nice little twist of logic. But when you say, Ernie, how could you switch that? It's called contrapositives, all right? The conditional sentence said a certain thing, and we can switch the converse of the inverse, which is what happened right there. That's the magic step. Because now, see, the M's go away, the not L's go away. We have a new statement that says, hey, if this all were true, Jack's jumping rope, Peter's going to paint pictures, and all is well in Mathline world. How about it, all right? Thank you for tuning in today. Remember, we got Facebook going on all summer. We've got YouTube going on all summer. You don't want to miss out on it. We got summer school. We've got test prep. We have a busy, busy summer coming your way. Thank you for being with us throughout this year. Thank you for taking good care of us as we come on each day to try to give you a little bit of math knowledge and also to help you out when you need it, all right? Be sure you keep us checked out, and we'll be back in the fall. We'll keep you posted. You know that. We will take good care of you. In the meantime, again, thank you for tuning in today. Thank you for the many of you who've called in throughout this season, and we will come back. We'll be back for season number 6. Isn't that exciting? And again, we'll see you next time.